In section 4.9, you will graph and solve quadratic inequalities. First, we're going to graph a system of quadratic inequalities. Remember those steps for graphing an inequality? We first graph the boundary by replacing the inequality with the equal sign. So to graph this parabola that's opening up, I'm going to find that x-coordinate of the vertex. And since my b value is 0, 0 divided by anything is going to be 0. My x-coordinate of my vertex is 0. And when I substitute 0 in for x, I get -3 for y. So I'm going to graph that vertex, 0, -3. And then I'm going to determine how wide this parabola is that's opening up. I'll put -2 in for x. -2 squared is 4. 4 minus 3 is 1. And I know that if I choose a value for x equally spaced on the other side of the vertex, I'm going to get another y value that's 1. So I'm going to graph -2, 1, and +2, 1. Now when I draw this parabola opening up, I'm going to have a broken U shape because equals is not part of the inequality. And when I check for shading, I'll use the origin since it's inside the parabola and not on the boundary. When I put 0 in for y and 0 in for x, I find that 0 is greater than -3. That's a true statement. So inside this parabola is where I'll shade. And then I'll graph the second parabola by first graphing the boundary, y equals -2x squared plus 4x plus 2. Okay, my x-coordinate of my vertex, my b value is 4, and my a value is -2, so I'm getting -4 over -4, or 1, for an x-coordinate of the vertex. And when I put 1 in for x, 1 squared is 1, 1 times -2 is -2, 1 times 4 is 4, plus 2, so it looks like I'm getting a y-coordinate for my vertex of 4. So I'll graph 1, 4, and this parabola is opening down because my a value is negative. Again, I want to know how wide, so I'm going to put in -1 for x. -1 squared is 1, 1 times -2 is -2, -1 times 4 is -4, plus 2. So I'm finding that I have a y value of -4. Now if I choose a value again for x equally spaced, like 3, I'm going to get y value of -4 again. So I'm going to graph -1, -4, and +3, -4. Now this boundary is solid because equals is part of the inequality. And I'll check for shading again using the origin, which is again inside the parabola. And if I put 0 in for y, is that less than or equal to -2 times 0 squared plus 4 times 0 plus 2. And of course 0 is less than or equal to 2. That's true again. So I'm shading inside this parabola opening down also, which means the overlap, the solution to the system, is in this region. And it includes the parabola, the solid parabola opening down, but not the broken parabola opening up. Now we're going to solve quadratic inequalities in one variable using 3 different methods, and the first method is using a table. So to use a table, I'm going to get this quadratic inequality in standard form by subtracting 8 from both sides and getting 0 on the right. Okay, then I'm going to make the table, my input values will be x values, and my output values will be x squared plus 2x minus 8. Okay, so I'll choose some values for x along the number line equally spaced. and I'll find those output values. I'll put -6 into the quadratic. -6 squared is 36. -6 times 2 is -12 minus 8. So I have -20 plus 36, that's 16. Now -5 squared is 25. -5 times 2 is -10 minus 8. So that looks like +7. -4 squared is 16. -4 times 2 is -8. Minus 8, I'm getting 0. And -3 squared is 9. -3 times 2 is -6. Minus 8. That's -14 plus 9, -5. -2 squared is 4. -2 times +2 is -4. Minus 8. So I'm getting -8 for an output value. -1 squared is 1. -1 times 2 is -2 minus 8. That's -9. If I put 0 in for x, I can see that I'm going to get -8 for an output value. If I put 1 in, 1 squared is 1. 1 times 2 is 2. Minus 8, that's -5. And you can see that our values have reached that parabolic shape, and my next value then will be 0. 3 will give me 7, and my x value 4 will give me 16 again. Okay, so the values that satisfy this inequality, the values that are greater than or equal to 0, the x values that are less than or equal to -4 will satisfy the inequality, and the values at the other end of this table, greater than or equal to 2, satisfy the inequality. So the solution to the inequality is x is less than or equal to -4, or x is greater than or equal to 2. The second method we'll look at for solving a quadratic inequality in one variable is graphing. We can take this quadratic inequality and we can replace the inequality again with the equal sign. And 0 with y. This is our quadratic equation that when we graph will be a parabola opening up because a is positive. So for this parabola, in order to graph it, I'm going to find x-intercepts. So I'm going to let y equal 0, and I'm going to solve for x, but I'm not going to try and factor this trinomial because of that a value that's a fraction. I'm going to use the quadratic formula to find my x values or my x-intercepts. So x equals -b, and b is 3, plus or minus the square root of b squared, which is going to be 9, minus 4 times a, which is 1/2, times c, which is -2, all over 2a, or 2 times 1/2. So simplifying, I get -3 plus or minus. My two products underneath this radical are 9 and +4. In the denominator, I just have 1. So in the calculator, I'm going to put -3 plus or minus the square root of 13 in order to approximate these x-intercepts that I'm going to graph. So if I put in -3 plus the square root of 13, I'm going to get 0.61 for an x-intercept approximately. Or if I put in -3 minus the square root of 13, I'll get -6.61. And now graphing those x-intercepts, I'll find one here and one approximately here on the x-axis. Now I'm going to draw this parabola opening up, and I don't really care about the vertex. I'm going to draw it broken since equals is not part of the inequality, and I'm going to check for shading. I can use the origin since the boundary is not does not go through the origin, and I'll put 0 in for x, and I'll put 0 in for y, and this inequality is true. -2 is less than 0, So I know I'm shading inside this parabola that's opening up. The origin gave me true statement. And now the solution to this inequality in one variable is found along the x-axis. Since equals is not part of the inequality, we're going to have empty circles at those x-intercepts, and the values between the x-intercepts satisfy the quadratic inequality in one unknown. So this solution is x is greater than 0.61 or negative 6.61, and x is less than 0.61. Our third method is an algebraic method, and to use the algebraic method, I'm going to replace the inequality with the equal sign again, and I'm going to solve this quadratic equation for x. I can make it simpler by dividing every term by 3, so that I have x squared minus 3x minus 4 equals 0. And then I can factor this trinomial and use the zero product property to solve for x. Factors of x squared are x times x. Factors of 4 that have a difference of 3 are 4 and 1. I need to make the 4 negative and the 1 positive, so that negative 4x plus positive 1x is negative 3x in the middle, and negative 4 times positive 1 is negative 4. Now using the zero product property, I'll set those factors equal to 0 and solve for x. So I'm getting x is equal to 4 or negative 1. Now these are critical values that I can graph on a number line. So I'll graph 4 and negative 1 with empty circles, since equals is not part of this inequality. And then I need to check a value in each area. I'll check negative 2 in this area. I'll check 0 between those critical values, and I'll check 5 to the right of that second critical value. So if I put negative 2 into that inequality, negative 2 squared is 4, 4 times 3 is 12. Negative 2 times negative 9 is positive 18. Minus 12, is that less than 0? And I know that 18 is not less than 0. This is a false statement that I get in that region. Now I'm checking 0. If I put 0 in for x into this inequality, I get that negative 12 is less than 0. Now that's a true statement. So I'm getting true values in this region, so I'll shade it in. And then I'll check 5. 5 squared is 25. 25 times 3 is 75. 5 times negative 9 is negative 45. And minus 12, is that less than 0? But I can see that I'm going to get a positive value, 57. So am I getting 18? Is less than 0. Now that's false. So I know that my solution is between my critical values, and my solution then for x for this quadratic inequality in one variable is x is greater than negative 1 and x is less than 4. Include with your notes of this video guided practice problems 2, 4, 5, and 7 found on pages 301 to 303 of your textbook.